Again, in this series of videos, we're focusing on covalent bonds, molecular compounds, and how do we describe how those molecules bond to inform us a little bit about their reactivity, their molecular geometries. And in this video, we want to focus on how can we describe the way that our orbitals overlap to form those covalent bonds. Because we can talk about shared pairs of electrons, but for those electrons to be shared, those electrons need to occupy a space or a volume between my atoms to make that happen. And so that's where valence bond theory comes in. Valence bond theory wants to explain how electrons get shared between two atoms, and they do this by the overlap of their valence shell orbitals. So we talk about our valence orbitals when we think about bonding here. And this occurs, according to valence bond theory, when the two atoms come close enough to each other to form a spatial overlap of those atomic orbitals. And the way that they share those electrons is by having opposite spins in the overlap of those atomic orbitals. Those two atoms are oriented in a way where we see a maximum of overlap between those two atomic orbitals. And that gives the greatest amount of sharing between those two electron pairs, and that's going to give us the lowest energy, which would mean we're going to find the strongest possible bond formed between those two atoms when they go ahead and overlap to the maximum extent that they can. So we want to look at maybe an example of this with the fluorine-fluorine bond that forms in F2. So let's use valence bond theory to describe and explain how the bond forms between fluorine and fluorine in F2. For us to do that, we maybe want to look at what each of these fluorine atoms look like in F2. Now we have our Lewis structures here that informs us of the fact that we form one bond between these two atoms. And that lets me know in my, for example, atom 1 or fluorine atom 2, we can diagram what those two sets of electrons look like. So for example, in my first fluorine atom number 1, we look at our valence electrons. They're occupying the 2s and the 2p orbitals. So we can draw an orbital diagram to illustrate where my electrons are. So now we notice here that I have one orbital that has a single electron, meaning it has the ability to overlap with another orbital and share that electron with the other atom. Now again, if I look at my second fluorine atom here, we'll find that it has the same valence orbital diagram, where I have 2 electrons in 2s, and then again, 5 electrons in the 2p. Now we'll notice for the bond to form between these two, my electrons need to have opposite spin. So one has up spin, one has down spin, one has positive 1/2 spin quantum number, one has a negative 1/2 spin quantum number. So now that we've kind of defined this and see these orbitals will overlap to form the covalent bond between our two fluorine atoms. So we can describe this in a couple ways. One of them would be to kind of explain what's happening here. And we'll say the fluorine-fluorine bond forms by the overlap of the 2p orbital of maybe fluorine number 1, that we might describe these two atoms, with the 2p orbital of fluorine number 2. Again, we're comparing these two different fluorine atoms. They're calling 1 and 2 just arbitrarily. So we see it's an overlap of those two orbitals, and that's kind of describing now how the bond forms. It's the overlap of those. We can also maybe visualize what this might look like if we think back to what our orbitals look like and the shapes that they form. I'm not going to draw every single valence orbital. All I'm going to do is draw the ones that are going to overlap to form my bond here. So I'm going to draw the 2p orbitals that overlap for fluorine to form this bond. So again, if I think of fluorine atom number 1, this would be its nucleus, and the 2p orbitals might look something like that. Now this would be the one 2p orbital that has a single electron in it. I'm not going to draw the other ones that are perpendicular to this because they are full and they're not going to overlap with another orbital to form a bond, because they would then have 3 electrons in orbital, which would violate the Pauli exclusion principle. Now we go ahead and we look at our other fluorine atom. So again, this would be maybe our nucleus of our second fluorine atom. And again, we have our atomic orbitals for these 2 fluorine atoms here. And now we see we have this other electron here that has a downspin. And so now what we find is that the overlap of those 2p orbitals forms the shared space for our covalent bond to form. And this would be described by what we said earlier about the 2 orbitals that overlap, and now we've visualized it here. And now we can see we have made it that we've paired up those electrons. And now if we think of what each of these individual orbital diagrams might look like, is now I can think of this other fluorine atom now seeing the other electron. Likewise, this second fluorine atom also seeing the other electron, and now they both have a full octet as they've shared these electrons with each other. So this is how we can use valence bond theory to describe and explain the orbitals that overlap when we form the fluorine-fluorine bond. So we have the ability to visualize what this overlap might look like. So I have one of my fluorine atoms, I got my nucleus, surrounded by these 3 sets of p orbitals. So our blue one is one set, this other green one is another set. These were my 2 ones that have a full pair of electrons. And then we have this other green one that's shaded in, and we see we only have a single electron here. And so now if I think of that same thing for my other fluorine atom, where now I see I have this single electron and this single electron, when those 2 orbitals overlap, they're going to form my covalent bond. And this overlap right here in the middle is what forms that covalent bond between these 2 fluorine atoms. And now we've paired up those electrons, and we've caused each fluorine nucleus to see the specific electrons that are shared between those 2 atoms. And that's how we can use valence bond theory to describe the specific orbitals that overlap when we form this covalent bond here.